I love math. I love math.
Hey guys, let's go over the Integrated Math 3 Module 8 practice test. It's going to be given to you guys September 27, 2021. Directions: complete any 10, so you don't have to do all of them, just 10 of them. Feel free to do more, but that's optional and not extra credit. For each question, make sure to show your work. For multiple choice questions, write a sentence explaining why you chose the answer. Question 1, determine whether each question is if it's biased or not. Remember, bias just means does it lean towards one, push you in a bad way towards one or the other. Question number 1, would you like to have a really tasty cupcake or a slice of pie for dessert? Well, maybe you're a waiter or waitress trying to make more money on tips, but I think that's a little bit biased, right? They're trying to sell me on something that's very tasty. Question 2, where do you attend elementary school? This to me is unbiased. Remember, unbiased means it's a fact question, right? No emotions. How many vegetables do you eat daily? That is unbiased. You can say 0. And D, don't you agree that schools should offer more choices for foreign languages? So this part, you might be kind of scared, and so that would be a biased question. Question number 2, feedback. Chandra writes a blog and would like to receive feedback from the readers who have an email subscription. All right, I'm going to underline that one. Email subscription. She sends a questionnaire in Monday's email and asks the responders to respond. Classify the method. Okay, she did not break up her readers. In her readers list, she's not saying every 5th person, so that would be systematic. I have self-selected and convenience. So convenience would be what is easiest for Chandra. She could just say the first 10 people on her readers list. But here, this is self-selected because she's just going to email them and the readers who respond, right? There's our keyword, so our answer is going to be self-selected. We forgot to write why I wrote each of these. You can write, well, it's tasty. These are unbiased because they're just facts. So write a sentence about that, and they don't want you to feel bad. Feel bad. Self-selected is just those who responded. Just those who responded. So again, stratified is you put them into like groups first. And then you take an SRS, simple random sample. Systematic is like every 5. And convenience just basically means like a convenience or whatever's easy, and that's not what you did. Okay, question number 4. Match each study with a study type being used. Remember, observational study is just whatever you observe. Experiment is something you do to them, and a survey means you give them or you ask or you give them something. Okay. 3A. To determine whether the patrons of a local fitness center like new exercise equipment, the owner asks a random sample for their opinions. So if you're just asking someone for their opinion, they're just going to give you their opinion, right? So that would be A. This one is A. A florist, let's write that. Giving their opinion about gym equipment. Okay. B. A florist is testing a new plant food that should allow fresh cut flowers to last longer. She randomly selects half the cut flowers and applies the plant food and records the results. So she's doing something. She's only giving half the flowers this new plant food. So she's giving or doing, that would be B. Florist gives new plant food. And that's why it's an experiment. She wants to compare, right? Does that stuff actually work? Okay. C. Researcher observes toddlers playing with a newly developed toy and record the reaction. So they're just watching. So that would be C. Watching toddlers to see reaction. Keyword there is watching or observing. Okay, question number 4. Miss Jenkins owns a restaurant, and she wants to offer 2 new soups on the lunch and dinner menu. She plans to conduct a survey, let's underline that, survey, to find out how many customers would choose each of the 8 possible soups that could be added to the menu so that she can select the top 2 to add to the menu. State the objective and population of the survey. Okay, what do you think she's trying to do here? Well, I think here the objective of the survey is to determine which 2 soups customers would like to be added to the menu. To be added Okay, question. Who is the, so we did that one. Who is the population? So the population here would be all restaurant customers. Okay, let's try the next question. Question number 5. An equal number of each color of marbles were placed in a paper bag. One marble is selected and the color is recorded, and then the marble is returned. This process is continued 250 total times, and the results are shown in the table. The theoretical probability of selecting a green marble is, and then the experimental is, okay, the theoretical is what should happen. What should happen? And there are 1, 2, 3, 4, 5. Let's just say you place, remember, probability is your select over your all. So all is we have 5 colors and you're trying to select, what color are we getting? Blah, 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 green. So there's only one green out of the 5 colors. So that would be 1/5. And that would give you 0.20 if you put in your calculator and then multiply by 100, you get 20%. So the answer there would be C. Okay, so what is the experimental? The experimental probability is basically what happens over here. So our select is green. And how many green do we have? 38. And then our total is all marbles, and we have 250. Or you can just add all these up and get 250. So if I put that in my calculator, 38 divided by 250. There's our decimal. And then if I multiply by 100, this gives me a percent, 15.2%. So that would be choice A. A random number generator was used to select a number from 1 to 8. A number was selected 120 times, and the results are shown. Complete the statement below, round to the nearest 1/10 of a percent if possible. Okay, so the theoretical is if you have 8 numbers. Remember, theoretical is just what should happen. It's select over the all. So if you're trying to select a 7, there's only one 7 over how many numbers? 8. And so if you divide those, you will get 0.125, and then multiply by 100, you will get 12.5%. So 12.5% is our answer. The experimental probability is basically what happened up here when you ran the simulation, when you actually did it. Okay, so we wanted a 7, so that would be 18 of them, and our total is 120. Again, you can just add all those up and you should get 120. So 18 divided by 120 is 0.15, and multiply by 100, you get 15%. So in theory, 7 should have only came up 12.5% of the time, and then actual, or in our experiment, it comes up 15% of the time. All right, promotions. A special message is written under the cap of each bottle of Rossio's famous root beer. There is a claim that 1 in every 20 cap wins a prize. Identify the simulation that can accurately test the claim. Okay, so I need something that can equally get me 1 out of 20. And 1 out of 20, you can multiply by 5, and you'll get something like this. You'll get 5 over 100, so that is 5%. Okay, so let's take a look at this. Let's go D. Use 2 dice. Tossing 2 6s represents a winning cap. Well, if I need 2 6s, this is only going to come up once. That's a double, so that's 1 out of 36. So that's a no. And then question C says use 20 marbles. 5 are red, 12 are green, 8 are blue. Choosing red represents a winning cap, and all other colors represent non-winning colors. Okay, so 5 represents 5%. So this one would be good. No. That's wrong, because there's only 20 marbles. So that represents 25%, which is wrong. Okay, let's try B. Use a random number generator with numbers 1 to 20. A selection of 1 represents a cap, and all the other numbers represent non-winning numbers. Okay, that one looks good. And let's just double check by doing the last one. Use a spinner with a red section that is 20% of the area. Okay, so 20% is not the same thing as 20 here. 20% represents 20 out of 100, and ours is 5 out of 100, so that would be wrong. So hopefully you caught those mistakes just like I almost missed it. So B is our correct answer for number 7. Number 8. Consider information from exercise 7. If 240 bottles of Rossio's famous root beer were purchased, how many bottles would you expect to have win in the caps? Okay, so our expect to win is our probability times total. So I have n equals 240 here, which is my total, so that would be times 240. And then we have a 5%, so 0.05, and then if I multiply those two, 240 times 0.05 should give me about 12 is my answer. I expect to win 12. So no, 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 and then yes. C. Number 9, calculate the mean and standard deviation for the dataset, round to the nearest tenth if necessary. Okay, so I'm going to take those numbers, and if you have your phone or graphing calculator, I'm just going to punch those in. So the calculator commands are stat, edit, go to the top of your list, press clear, and then clear, then enter, then they go away. Okay, let's go ahead and input all those numbers. 16, 18, 23, 17, 15, 22, 21, 19, 26, 17, 14, and 18. I'm going to press stat, calc, var stats. And it's already on list 1, so that's the default, which means you don't have to press it. So you can just press enter. And here, the X bar is 18.9. And then the standard deviation here, double checking I have my numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Uh-oh, I only have 11 numbers. Oops, I did it again. 16, 18, 23, 17, 15, 22, 21, 19, 26, 17, 14, and I forgot the last one. Stat, calc, var stats. Okay, X bar is 18.8, and our standard deviation there looks like OX is because we have all the numbers, it's not taken from a sample, so it's not SX, that would be a sample. So this would be 3.38 or 3.39. Let's write that. So that was X bar, and this one was the population. Standard deviation, again, because you have all of the numbers. This does not come from a sample. Like if I had a class of 40 students and then I say how many M&Ms can you eat in 20 seconds, right? Without choking or something. Okay, number 10. The test scores for all students in the physics class are shown. Find and interpret the standard deviation. Okay, so I'm going to underline this one. Says all students, and I want standard deviation. So I'm going to go ahead and input these numbers into the graphing calculator. All right, let's go here, stat, edit. I'm just going to put this under list 3 just because I don't have to erase it. And I'm just going to go across 76, 93. I'm going to go a little bit slower because I know I missed a number. 72, 95, 83, 94, 82, 84, 98, 78, 82, 70, 86, 71, 74, 68, 84, 81, 91, 84, and 93. So that was a 5 times 5, and it should be at 25. Okay, I missed some numbers. Oh, Mr. Ring. 76, 93, 72, 95, 83, 94, 82, 84, 98, 78, 82, 70, 86, 71, 74, and then 68, 74, 68, 84, 81, and 93. Okay, I missed the first 4 digits of the 4th row. So 77, 88, 85, and 70. And you have 25 numbers there, so stat, calculate one of our stats. To get list 3, you have two options here, where I put mine, second and then the number 3, or you can do second stat. I like just using what's on the keyboard, so I'm going to press the yellow button, orange one second, and then number 3. Okay, this gives me an X-bar average of 82.36 and a standard deviation of 8.51 aux. Okay, let's write that. Whoops, wrong one. The mean was 82.36 with a standard deviation. That's the O with the symbol and then an X below of 8.51. Okay, so then you can use the empirical rule in this problem. (68, 95, and 99.7). And that's one standard deviation, two standard deviations, three standard deviations away. So then we can say something like this. Actually, not that one, this one. Most of the students, and what percent of that of our students? 68%. Scored between. Now, if you take that number, one standard deviation, so if I do X bar minus the mean, that'll give us one range. And then if I add the number, so 82.36 minus 8.51, and then 82.36 plus 8.51 gives me a range of about 68% of my students. So 82.36 minus 8.51, 73.85, and 82.36 plus 8.51 gives me 90.87. And 90.87 on the physics test. All right, question number 11, spelling. Miss Karuma gave a spelling test to her second and third period Spanish classes. There were 20 words given, and a number of correctly spelled words are shown in the tables. The average score is higher for which period? So average score, again, is your average. And then the scores were more varied. Varied means variation. And that would be our standard deviation. So I'm going to go ahead and put in both those lists. We'll call this one list 1 and this one list 2. And there are 16 students in each class. So let's just put this like a chart. And I'm going to have the average, should be actually the mean of that one. Because you have the whole population of the class, and then the standard deviation. All right, let's go ahead and pump in these numbers into the list. Clear, stat, edit, list 1. I'm going to press clear, enter. And then every number I'm just going to press 20, enter, 10, enter, 20, 15, 18, 18, 19, 20, 14, 17, 18, 19, 16, 14, 16, and 14. I'm going to go up to list 2. I'm going to press clear, then enter, and then enter those numbers for period 3. I'm going across 19, 8, 20, 10, 12, 17, 20, 16, 18, 16, 18, 18, 17, 14, 12, and 19. So I'm going to press Stat, Calc, one var stats. Remember, if I press Enter, this is the average. I'm sorry, this is for period 2. So 16.75. Write that down, 16.75 and 2.73. Okay, so I got that information down, and then I'm going to press Stat, Calc, one var stats, and then I'm going to put in list 2. So that'd be second, number 2, second, number 2. And this would be a 15.88 in the SOCS, which is your population standard deviation 3.53. Okay, so if I go back, whoops, wrong one. And 16.75, 15.88, 2.73, and 3.53. All right, so which one had a average that was higher? That would be 16.75, so that would be period 2. And then which one has more variation or higher variation? A higher variation just means a higher, and this would be period 3. Okay, so to help you again remember understand what variation means is that there's a bigger spread between the numbers. So if you look at the period 3, you have an 8, and then you also got someone who got a 20. So you got a really low and a really high score. That means the scores are all over the place. There's lots of spread. There's lots of variation in the scores that students were getting. Okay, question number 20, beekeeping. Melissa has 4 hives in 2 different areas. She recorded the annual total honey she has collected from each area using area since she began beekeeping. Table shows the total honey in pounds. Which statement describes the data? So I'm just going to do the same thing as we did in the last problem and put this in list 1, this one in list 2. And then I'm just going to get some numbers here. I'm trying to find the mean, or which is the better one is that one on the right, and then the standard deviation here. Let's go ahead and put in those numbers, and then we can compare them. So stat, edit, go up to list 1, press clear, enter, and then I'm just going to go across 80. I can't even write 80. 80, 126, 104, 92, 88, 98, come on, blah, 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 114, 116, 88, and 106. Go up to list 2, press clear, enter, and then go across again, 74, 98, 96, 112, 102, 94, 106, 110, 104. Stat, calc, one of our stats. That gives me the list for 1, so the average is 102.7. And a mean kind of looks like an OX, or it's really a sigma X, 13.86. And then do the same thing, stat, calc, one of our stats, L2. I'm going to use a different command to get the same thing, second stat, and I'm going to press L2 there. 99.56 and 10.70. So let's just go ahead and write that in here. So I got 102.67, 13.86, 99.56, and 10.70. So then yard A, or list 1, let's just write that above. A, this is my B. A produces more, so yes, this would be wrong because it says B, so no. And then what total is more spread out for A? A is more spread out. So with totals amounts more spread out from the, or less spread out from B. So that would be true. And so then my answer, wait, let me go back again. With the total amounts more spread out from the mean, A is bigger than B. That's what it's trying to say. Kind of confusing. The hives in yard A produce more honey on average, yes. So it's still, the subject is yard A. Yard A, so pick up here, has totals more spread out than yard B, because A is bigger than B. So it'd be this one. Because if you read the sentence on this next one, yard A produces more honey, yes. But right here, it's saying yard A has less spread, or a smaller amount, or less than B. That's false because A is bigger than B. So A is our correct answer. Number 13. Classify each random variable as discrete or continuous. Okay, so I'm looking at my formula sheet, which is basically a condensed version of my my notes, and I wrote that discrete means you do a count, and continuous just means can be any number, like a decimal or fraction. Okay. 13. A, number of visitors to a website each hour. So a visitor is a whole person, so that would be discrete. Level reached on a video game. Well, a level, you can't go to level 2.78. You can only go to like level 2 or level 3. So that would be also discrete. Distance ran in 30 seconds. Well, that one would be continuous because you can get like 37.6 feet. You can go 41.9 feet or 50.0 feet. Total snowfall in a city each winter, you can do fractions or decimals, and that would be continuous. Question number 14. A normal distribution has a mean of 24.8 and a standard deviation of 1.6. Find the range of values that represent the outer 5%. Okay, for this one, I'm going to have to use my, they want to know X values. They want to know the value on the picture. So this, I want to list out though, that this is not a percentage. You're not finding a percentage. So let's do the same thing we did. Let's go ahead, and the first thing I'm going to do is I'm going to draw a picture. Here's my normal curve. Okay, so when it says find the range of values that represent the outer 5%, to me, that means that this is 5%, or in a decimal 0.05, and this represents 0.05. Let me think about that. Nope. I'm going to take that back. I think 5% means 2.5% plus 2.5%. And 0.025 is, you know, this region over here. And why I say that is because if you add those together, you get what? This represents 5%. So 100 minus 5% will give us 95%. And then this number is going back to our normal distribution, which is our already listed amount above is our empirical rule, which is the 68, 95, 99.7. Does this make sense? And the big idea in this one is this is 1 standard deviation, 2 standard deviations, 3 standard deviations away. So let's try to color code this so you can see this. The mean is a measure of center. So I put that right in the middle. So the mean is 24.8. Does that look like a 24? 24.8. Kobe, double Kobe, sorry. And, okay, so, whoa. What happened to Kobe? Okay, now the standard deviation of 1.6 just basically means we need to add 1.6. That would give me here. And then we add it again, would give me there. And you would subtract 1.6. Okay, how did I know to do that? Well, remember, this is 1 standard deviation away, and this is another standard deviation away. So that first orange mark right here with my black dot, that represents 1 standard deviation. This one, you go count 1, 2, this green dot here represents 2 standard deviations away. Okay, so let's just add here 24.8 plus 1.6. This gives me 26.4. So basically you're just adding 3.2 to 24.8. And that'll give us 28. Okay? All right, let's go the other direction. Pick a different color. So now this is 1 standard deviation away, 2 standard deviations away. So I really need 24.8 minus 1.6 minus 1.6. And this would give us 21.6. And those are the 2 numbers that I needed. So the x value, they're saying under the distribution, has to be, if you want the outer 5%, you have to be a number less than 21.6. And this one would be a number greater than 28 to get the yellow shaded region. So tricky question, but that's what it means there. Okay, let's go to question number 15. Our normal distribution has a mean 74.8 and a standard deviation of 4.5. What is the percent of the data that would be less than 83.8? Always in math, draw a picture. So here's my picture. And I'm going to go ahead and draw the center, 74.8. And it says it wants 83.8. Okay, where's 83.8? It's got to go to the right. Right? Because this is like, I don't know, 0, and this has to be like 1 million on a number line. So that tells me I kind of need to keep adding 4.5 to the right. So let's see if this hopefully lands to empirical rule, and if not, then I have to use a z-score and use a table or use our graphing calculator. So let's go ahead and do that. So let's go ahead and add 4.8 or 4.5. 74.8 plus 4.5 gives me 79.3. Not bad. All right, let's do it one more time and see if we get lucky. Yes, yes. I'm so happy because I don't have to use the table. Okay. So let me just mark off the other areas. Pencil, come to me. Okay, so it doesn't matter really what these two scores are, but I just want you to hopefully... Okay, so from the center, this is 1 standard deviation away here in yellow. This represents in the empirical rule 68% of the data. Okay, pay attention. Now, the green area combined represents this direction. It represents 95%. Are we okay here so far? Okay, so it wants to know what percent of the data will be less than 83.8. So let me go ahead and just draw a picture here. It wants to know all of this. Okay, so let's get another color. How about this blue here? We're trying to find one of the tails. And we already kind of found the answer from the other one. So watch this. So if this is 95%, 2 standard deviations away, that's the whole green area. That includes the yellow. So that's 95%. Let's just, yeah, 95%. That means this area would be like an X, and this would be an X. So you can technically do X plus 0.95 plus X. And remember, a total probability distribution equals 1. So if you combine like terms, I get 2X plus 0.95 equals 1. If I subtract the 95 from both sides, I get 0.05. And if I divide by 2 on both sides, I get 0.025, which is 2.5%. So each of these x's here represents 0.025. 0.025. And so basically what I'm doing here is I'm adding up 0.95, because this will represent the red region. And if you add those up together, that's a plus. You will get 0.975 or 97.5%, which is letter choice D is my answer. All right, question number 16 says, what is the value of Z? So that means they're asking Z is equal to what? If you know the X, standard deviation, and the mean. So the formula, if you look back, Z equals X minus the mean over the standard deviation. And you just substitute in these values. So X goes there. .6 minus our standard deviation is 2.8. And then the mean is 9.2. So if you put that into your calculator, 38 minus 6, let me grab my calculator here. And divide that by 2.8, you'll get 10.5 as your answer. All right, question number 17. Screens. Charlotte surveyed 420 chosen students at her school, asking how many hours they spent looking at a screen during the week. The average time spent was 24.8 hours, with a standard deviation of 3.9. Use a 95% confidence interval to find the maximum error of the estimate of time spent looking at a screen. Round your answer to the nearest hundredth. Okay, so let's highlight some information here. I see n equals 420. I see the mean here is 24.8. I see that the standard deviation of this sample is 3.9, and I see a 95% confidence interval. So if I look back at my notes, the first thing that I probably want to do here is write down a formula. To find the maximum error. This is E, or another way of saying is margin of error. So the formula is E equals Z times S divided by the square root of N. Okay. To get Z, you're going to have to use the 95% confidence interval is you're going to get a z-score of 1.960 from our notes. Okay, so I'm going to use this one for that value. So E equals 1.960. The S is 3.9. And the N value is 420. Don't forget the square root. And remember, to make this side a fraction, you just put it over 1. So essentially it is 1.960 times 3.9. I'm going to take a picture and I'll do that with you so you can see that step by step. Okay, so go to my calculator. I'm going to type in 1.960 times 3.9 divided by the square root, which is second, and then up here by the 7 is in orange, the square root 420. Press right key to get out, and then close the parentheses. And that gives me an E value of 0.372, and tells us round to the nearest hundred. So 0.372. 0.37. So we could say with 95% confidence that the mean time spent watching a screen per week is 0.37 hours of the sample mean time. So we're pretty close. All right, question number 18. A website asked 842 chosen viewers, so N equals 842, how many times they visited the site. The average number, so our average, if we needed it, x bar equals 2.8, and a standard deviation, S equals 0.4. Use a 99% confidence interval to determine the maximum error. So this is, let's put it here in yellow, to determine the maximum error of an estimate. So what is your E value? And then it says estimate the population of the mean. Okay, so what we can do here is we're going to do the same thing. First thing I'm going to do is confidence interval, which is 99%, to a z-score. And if you look at your chart, that is 2.576. Z equals 2.576. And that was not to have any decimals right there. My pencil right now. Oh, that's why it's playing an object. Okay. All right, the second thing I'm going to do is calculate E. Same formula from above. And remember our z-score we just figured out from the confidence interval. So I have E equals 2.576 And then my S value came from up here, 0.4. And then I'm going to divide that by the square root of n. So n is square root of 842. Take a picture. Remember the not cheating way, is just calculator command. Second enter basically repeats everything, and then it might be just easier to put everything in there. If you don't want to do that, there's another way. Alpha, the green button, then y equals. And it says fraction there in green in the top left there. And I learned that from another student. N parentheses d. And then there you can put everything in the numerator, 2.576 times 0.4. And then second, x squared, 842. And remember, it's red, so you have to press right. And we get 0.04. Doesn't tell us right around, so I'm just going to be safe. 0.036. 0.036. 0.036. Okay. All right, the third thing I need to do now is calculate the population mean. To calculate the population mean, I'm going to get plus or minus the e. So, that value will come from 2.8. So let's write that. Whoops. Okay, plus or minus e. So this value goes here. And basically that just means you split it, right? So the mean could have a range of 2.8 plus 0.036 or 2.8 minus 0.036. That means the mean should be between this value, so 2.8 plus 0.036. This will give you a bigger value. So 2.836 and 2.86 minus 0.036 gives you a smaller number, which we put on the left. And this is my answer. All right, let's take a look at our multiple choice. Is 2.76 in there? No, no. $2.82. And then the right side, you have, if you had a round, I would go to a 4, so it would go this one. Okay, this one over here, we are incorrect. 2. Oh, there's my mistake. Let's try that again. 2.8 minus 0.036. And you will get a score of $2.76, 2.764. Okay, so which one is that? Too much, and your round, it would be this one. So A and C would be the correct answer. Okay, question number 19, break room. A business has surveyed 154 chosen employees, asking whether they supported removing the soft drink machines from the break rooms. A total of 28 people responded that they agreed. Okay. So this would be my X. Right? And using a 95% confidence interval, which estimates the population proportion. Okay, proportion should give you a hint that it's a fraction. It's a fraction. So let's get all of our variables. So the proportion I need is p hat is your x over n. So my x is the 28 and my proportion or n value is 154. Okay, so q hat is basically the complement. So if you took 154 minus 28, you'll get 126. So basically 28 plus 126 will give you the 154. So if you divide 28 divided by 154, I get 0.18. Okay, so another way of getting q hat is equal to 1 minus p hat. And if p is 0.18 from above, 1 minus 0.18 gives you 82. That means q hat is 0.82. And you'll notice these numbers, p hat plus q hat equals 1. Okay, so we got a bunch of variables. Okay, let's get a well, we wrote down all the steps. Sorry, estimate a population proportion. The first thing we should have done is check the conditions. And the best one is, we didn't go over this one, but in AP Stats, we would have used the acronym RIN. Is it random? Is it independent? And is the n value, is n value greater than 0.10? All right, the conditions we needed is n p hat greater than or equal to 5 and n q hat greater than or equal to 5. And if n was 154 times p hat 0.18, is it greater than or equal to 5? And then same thing over here, 154 times q hat, which was 0.82, is that greater than or equal to 5? And if I just punch those in my calculator, 154 times 0.18 gives me 27.72. And then 154 times 0.82, 126. Okay, so the conditions are met. It is a big enough sample size. Second one is, which we just did, the p hat and q hat. Okay, third step is we need a confidence interval. So a confidence interval of 99%. If you look at your chart from your notes, it gives you a z-score. And a z-score, the IC is 2.576. Okay, the fourth thing we need is the formula. That's this formula. E equals z times the square root of p hat times q hat over n. Now, if you get confused on this formula, I want to break down something. You can do the square root of p hat times square root of q hat over the square root of n. And that actually looks like our formula for finding the population mean. Okay, so let's just punch away in our formula. I need a z-score, which we got way over here. And let's just write that. E equals 2.576. Okay. Times our p hat value. Whoops. P hat is 0.18. And our q hat is 0.82. All over, because remember this is like z, you can make it a fraction by putting over 1. And then you still have the square root of n value, which is 154. All right, let's take a picture of this. Okay, so again, trick here is alpha y equals, gets me a fraction, n divided by d is numerator divided by denominator. And then I'm going to get 2.576 represents my z-score, open parentheses, square root, so that would be second x squared, and then 0.18 times 0.82, close parentheses. Click right, and then down, and then second x squared to get square root 154. Exit out, and then press enter. I get 0.079. 0.079. So if I round up, that would be 0.08. Okay, the fifth thing I need to do is now calculate the population proportion. And I get that by the formula p hat plus or minus e. So that would be p hat from up here p hat was 0.18 plus or minus the e value. So this would give me 0.08. So 0.18 plus 0.08 and 0.18 minus 0.08. And this would give me 0.26 and 0.10. So my proportion, p hat, has to be between, my p-value. Remember in the notation that p hat represents a sample, capital P represents the population between 0.10 and 0.26. And looks like some bad news. Our numbers are wrong. So let's go back. 28. Okay, Z was 0.95. I think that's it. Yup, that was the wrong number right here. Hopefully you guys picked that up. Obviously, I did not. 1.96. So we said z-score should be in yellow. That means right here. The z-score was 1.960. Let me put that into our calculator. Second entry. Okay, like press delete. 1.960 times. Okay, enter. This one right here. Delete that. Okay, that gives me 0.061. And then let's use that over here, because we said it was orange. Point 0.061, 0.061, 0.061. And let's see what happens. I think we should get a better answer. 0.18 plus 0.061 gives me 0.241, and then 0.18 minus 0.061 gives me 0.119. Okay, so if I probably rounded to 0.06, I'd probably get a closer answer. So what's a smaller number? I'm looking at close to a 0.12 and 0.24, which would be choice B. Whoa, too dark. Come back, come back, come back, come back to me. Would be this choice right there. So double check your confidence interval like I did, and it's good because I realized it wasn't one of my multiple choice. Okay, question number 20. Recommendations. A toothpaste company surveyed 25 dentists. Oh yeah, dentists are not as good as math teachers, and asked whether they recommend using the company's toothpaste. From the study, the company shares with 60% confidence, I'm going to circle that between 75% and 82% of the dentists recommend their toothpaste, and identify any misleading representations of the data. Okay, here is a couple of things that we should be thinking about. 25 dentist. So I'm going to check the conditions. And that's n times the p hat is greater than or equal to 5, and n times the q hat is greater than or equal to 5. To get a p hat value, I'm going to take the two values, 75 and 82, and we're going to find the average. And what this does, that would give you 157 divided by 2, and 75 plus 82 gives, 75 plus 82, 157 divided by 2 gives me 78.5. So we can use this as our p hat value. And so my n value was 25 dentists times, if you change that to a decimal, it would just be 0.785. Wah. And if I just take 1 minus 0.785, I get q hat to be 1 minus p hat. So q hat equals 1 minus the red one, 0.785. That gives me a q hat of 0.215. And let's just multiply those. Let's see what happens. 25 times 0.78. 25 times 0.785 gives me what? 25 times 0.785 gives me 19.625. What is that? Greater than or equal to 5. That is true. And then 0.215 times 25. Um, 53.75. So those conditions are met, but let's go ahead and look at our confidence levels. Is that one of our magical numbers from your chart? Is it 90, 95, or 99%? The answer is no. So no. Confidence interval is too low.
And a math commandment that states, "Thou shalt not write thy math papers in ink." If you do write your math papers in ink, you cannot undo mistakes. A pencil can undo mistakes with an eraser.